Hello everyone, my name is Nick Merrill. I direct the Daylight Lab at the Center for Long-Term Cybersecurity at UC Berkeley, and I am presenting a paper called Security Fictions, Bridging Speculative Design and Computer Security. At a very high level, this paper is about expanding the practice of computer security beyond specialists, beyond security specialists. To do that, we developed a game, Security Fictions, which I'll describe, and we reached into design research, and in particular speculative practices in design research, to inform the design of that game. And one kind of key observation motivated that shift, and that is that threat identification, that is calling out or identifying that something is a security threat, is an intrinsically speculative practice. It requires identifying threats that haven't occurred yet, that haven't been observed yet. So, there is already speculation involved when we talk about threat identification. But before we get into my game, let me tell you a little bit more about threat identification as it currently exists. So, the kind of canonical way to do threat identification is through a practice, or really set of practices called threat modeling. The game I have up here on the screen is a card game, so you can see we're not the first game here. This is called Escalation of Privilege. It was developed at Microsoft. This game is, designed to help, again, software engineers think about, what kind of threats their software may face. So there's this aspect of play, there's this aspect of speculation. There are two kind of major limitations to the games and practices that are out there. The first is that, threat modeling practices are often very difficult for non-specialists to learn. They require, specialized technical knowledge or specialized security knowledge, and the barriers to entry thus are quite high. The second, and really important to me personally, is threat modeling practices systematically fail to identify particular types of threats. One example we gave in the paper is from Diana Freed et al., Stalker's Paradise. You may have seen this CHI paper. It came out, I think, 2018. It's about how survivors of intimate partner violence are often subjected to stalking and harassment via, everyday devices and apps. And one of the reasons that this threat is not frequently caught is that threat modeling practices don't usually have you think about it. Threat modeling practices tend to focus on kind of anonymous attackers on the internet and miss, those attackers that might be close to home, might know the victim extremely well. So threat modeling practices, in summary, both they're difficult to learn for non-specialists, and they systematically fail to identify, especially these more kind of socio-technical threats. So our game kind of comes in to fill two of these gaps. It doesn't do so in a vacuum, though. We had two kind of really big inspirations here. The first is Friedman and Hendry's security and privacy threat discovery cards. These cards are almost a direct response to Escalation of Privilege. They're, card-based games and practices, but for discovering more socio-technical threats. Then the other thing, that really inspired us was value scenarios developed by Lisa Nathan et al. At UBC. These they're scenarios to help pump kind of intuitions about what matters in a socio-technical system. So we synthesized these two ideas together and added to it speculative enactments, which were pioneered by Elsden et al. These are enacted almost like role-play scenarios. They involve relatable characters and, I say role play, but there are really real world stakes here. That's part of the method. So, if you're a software developer, you'd be using these speculative enactments to discover security threats in your software. And yes, you're using role play to do that, but the security vulnerabilities in your software are very much real. So we synthesized these into a game that we called Security Fictions. So Security Fictions took the form of a one-on-one conversation between the researcher and the software developer. So we'd sit down with the software developer and we'd read them this prompt. I am representing a client who would like to perform some tasks with your platform. Leave your ethics at the door and tell me how my client can achieve these tasks on their own without your help. Following Elsden et al., the participants were fully in on the enactment. They understood that I didn't actually have a client. I was coming there, in order to play a game with them, and that the game was meant to elicit security threats, here was our first task. Our client wants to impersonate another user. Okay, here's another one. Our client wants to find the physical location of a particular user. And here's the third. Our client wants to find all of the politically conservative users. Okay, these scenarios are all inspired by recent events, recent work in SIGCHI and beyond about actual observed socio-technical threats. And we were curious to what degree software developers with, again, zero training and zero security-specific knowledge be able to find attacks that addressed these threats. So we did our deployment with 7 developers from 5 different companies. Each session lasted about an hour, and we did some joint coding and analysis to reveal common reflections and themes across the deployments. So what happened? Well, developers actually found vulnerabilities, real vulnerabilities, at 3 of the 5 different companies. What we found overall, and this is not super surprising following prior work, especially Diana Fried's work, is that a lot of these attacks were both UI bound, as in they happened in the user interface entirely, or they were social. They required socially manipulating users. And again, these are the kinds of attacks that all too frequently are missed by threat modeling practices. So we found some evidence that our game was able to elicit these kinds of missed or missing security threats. And even better, they required not very much training. So sounds like a success, right? Well, one of the things that really arose very quickly is that developers very frequently asked, what now? I don't know what to do now that I've found this vulnerability. And we found a lot of different kinds of responses to this basic conundrum. The first is kind of this idea that security is someone else's job. It's like, okay, listen, I have this vulnerability, but there's a security team. I don't know who they are, but I'm sure they know about this. So what we noticed here in general is that security as a process has this organizational texture that is difficult for developers to grasp or see. Often security as a job is hidden within the organization, even from other software developers. This creates these kinds of organizational dynamics that make it difficult for people outside of traditional quote-unquote security roles to address security issues even when they find them. One major outstanding question from this work is the basic question of how software divides its work between security and non-security components. How does the work of software get divided up? How do we label certain tasks security and certain tasks non-security? In practice, it's actually kind of a big ball of wax. It's difficult to disentangle security from non-security tasks. Some of our future work, which hopefully we'll be reporting on soon, is going to dig into these labor contingencies of security a little bit more. There are also some other caveats I'd like to add to this work. The first is that, while developers did find vulnerabilities, not only is it unclear how they'd fix these vulnerabilities, but they can't generate their own scenarios yet. We came to the developers with scenarios that we had constructed. Ideally, these developers would be generating their own scenarios. We'll be reporting on this hopefully sooner than later, but we'd like to add the generation of scenarios into this practice to create something that's a little more self-contained. Finally, I hope this work invites design research to come more into the fold of computer security. I think design research methods bring a sensitivity to the social power and labor contingencies that make security so tricky in practice. Labor and labor organizing has long been an interest in the design research community, and I would propose that security as a concept is somehow entangled with the idea of fostering dissent in the workplace, and I hope design research explores this a little bit more. Regardless, this work indicates that speculative practices like speculative enactments could find a home in the workplace. And I hope future work looks at taking some of these amazing design research methods and thinking about how they might get some effect in kind of corporate environments. So with that, I'd like to thank the William and Flora Hewlett Foundation for funding this work and the Center for Long-Term Cybersecurity. I'd also like to thank Sarah Fox, Richmond Wong, Nora Howell, Willie Arani, Dorothy Howard, and Stephen Weber for their amazing feedback along the way. And finally, thank you very much. In a normal presentation, I take questions now. For now, please feel free to email me if you have any questions about this talk.